Ladies and gentlemen, hello and welcome, coming to you not quite live from One Take Studios, where my camera is doing weird things with its focusing, so hopefully it's going to stay put for us. Alright, I'm going to attempt to not melt your brain today. We have two words, precision and accuracy. And a lot of times those words get confused with each other. They don't actually mean the same thing, and so I'm going to give you an explanation for each one and examples of each one. You want to make sure that you're paying attention, and you probably want to write this stuff down. Because again, in the moment, a whole bunch of things make sense, but your brain only keeps about 80, not even that much, it dumps out of your brain like 80% of what it hears. It only keeps about 20%. And so you want to make sure that you write things down, even if you're sure that it makes sense in the moment. All right, so precision and accuracy. Which one is which? What do they mean? We are going to start with precision. So precision refers to the level of detail that we have for something. And there's really two forms that this level of detail takes. One is that it can be the smallest unit, and the other is that it can be the smallest fraction of measurement. Why is my camera doing this? I have no idea. Life. All right, so either the smallest unit of measurement or the smallest fraction. Piece, tiny little bitty piece of measurement. Okay, that's what that says. You might say, hey, there's something in my brain, I think I get this. We're going to put that into practice. Okay, I have 3 examples, and I'm saying, please, for these examples, pay attention. I picked all 3 of them for a reason. Each one is slightly different, and it's going to show you something a little bit different. Okay, so first one up, I have 2 measurements. One is 3.4 kilograms, the other one is 3,421 grams, and I would like to know which one is more precise, talking about precision. Okay, you might look at this and go, well, this one's got more numbers, maybe this one's more precise. Or you might say, hey, this one's got a decimal point, maybe this one is more precise. Well, as far as smallest fraction, that little tiny decimal, that does have the smallest fraction, but this right here, the unit portion of things, this is the very, very first thing that you want to look at right here, all right? Always look at the units first. This is kilograms, this is grams. Which one is smaller, do you know? Kilo means 1,000, so this is 1,000 grams, and this is grams. Yeah, grams is going to be smaller. Therefore, dun-dun-dun, this one wins, this one is more precise. Not because of the numbers, it has nothing to do with the numbers in this case. It is just because, units-wise, this is kilograms, this one is grams. All right, so there's our difference for that. Okay, next one up. We have 3.4 centimeters versus 3.43 centimeters. If I look at my units, first place I check, centimeters and centimeters, they are the same. So right now, having the smallest unit doesn't do me a lot of good because the units are identical. So next I want to look at the smallest fraction. Well, okay, fraction is a word, and I like that word, but we could also use the word decimal here, the tiniest piece of a measurement. So this has 4/10. A lot of times we call it 3.4, but this is 3 and 4/10. This one is 3 and 43 hundredths. This goes to the tenths place. This goes to the hundredths place. This has more detail than this one does. And so this one is more precise. Again, not because of the numbers, not because of the units in this case, but because of the numbers. Because this one has more decimal values, we can get more detail. This one is more precise than this one. Okay? All right, one more example in this category. We have 3 feet versus 36 inches. All right, take a guess in your brain. Stop and pause, guess. Which one of these do you think is going to be more precise? Ready? Pause, think. Okay, what'd you come up with? Which one do you think is more precise? All right. The reason I chose this one is so we can see the comparison of units. The reason I chose this one is so that we can see the comparison of numbers. But this one might just mess with your brain just a smidge, because 3 feet and 36 inches, that's the same measurement. 3 feet is the same thing as 36 inches. So that might disturb your brain a little bit. So what am I looking at? Which one of these is more precise? Maybe neither one of them is more precise. Well, start with the units. For this first one, we said the numbers themselves don't matter at all. It all comes down to the units. Are these units the same? No. Feet, inches. Which one is smaller? Which is the smaller unit? Inches. Did you guess that one? Ladies and gentlemen, this one is more precise. Is it always going to be the second choice out of the two? No, it just happened to turn out this way. But because this is in inches and this is in feet, inches are smaller than feet. Inches wins, so to speak. All right, so that is precision. Comparing things, looking for the smallest unit, and if the units are the same, we're looking for the smallest fraction, the smallest decimal, the smallest piece that we can get, the most detail. All right, one down, one to go. So next up we have, go, you guessed it, dun 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 dun, accuracy. All right, so not the same as this. In fact, so much not the same as this is I'm going to take this paper out of the way. All right, we don't need to look at that right now. This is completely different. Accuracy is not precision. Accuracy is how close a measurement is to its actual value or its real value. So I'd like you to think for a second. I don't know, do you happen to have a scale in your house? I had a scale in my house. I ended up throwing it out. I liked the scale though. It was very nice. Every time I got on the scale, it said that I weighed 10 pounds less than I actually did. So if you're going to keep a scale, that's a nice one. It's very complimentary. Was my scale accurate? No, it was not. And my zoom, there we go. It was not accurate because it was not close to the real value at all. It was 10 pounds off. All right. So my scale was delightful, but it lied to me. It was not accurate. So let's pretend that we have something that is actually 5 grams. All right. We've measured it. An official measurer has measured it. We sent it to the doctor's office. It got measured. We sent it to the chemist. It got measured. And it's actually 5 grams. So this is the real value right here. And then we put this on 3 scales. And one scale, so 3 scales, scale number 1 told us that it was 5.01 grams instead of 5 grams. And the second scale told us it was 5.033 grams. All right, this is not going to be the same as a bathroom scale, by the way. This is something more scientific. And then scale number 3 said it was 4.98 grams. All right, so bad news. None of these scales is completely accurate because none of these gave us exactly 5 grams, which is the real value. So then of these 3, how do you decide which one is the most accurate? And so we're looking for which one is closest to 5 grams. Do you have any thoughts on that? The closest one might be above 5. The closest one might be below 5. We need to think about this. So here is my recommendation. I'm going to put a 1 here for scale 1. And I'm going to say, all right, it said 5.01. How far away from that really, how far is it from 5 grams? So if I subtract those, I get 0.01. Okay, so that's how much it's off. 5.01 minus 5 is 0.01. So this is off by, do you know how to say that? This is 1/100th. So that's 10th place, 100th place. This is off by 1/100th. Okay, let's go to the next scale, scale 2. How much is this one off? So 5.033, and this time it's minus, again, 5. How far is this one from the real weight, from the actual weight? If I subtract this, I'm going to get 0.033. Okay, let's just stop here for a second. Of these 2, how do you figure out which one is more accurate? We want the one that's closest, so we're comparing which one of these is the smaller number. Start at the decimal. 0. 0 compared to 0. All right, at this stage of the game, these guys are both tied. Go over one more. 1 versus 3. Which one is smaller? The 1. This is going to be the smallest value between these 2, and so right now between scale 1 and scale 2, this one is more accurate because this number is smaller than this number. So this was 1/100th. If we cover this, this is 3/100ths, and that makes sense. 3/100th is definitely bigger than 1/100th. But technically, again, do you know how to read this? Tenths, hundredths, thousandths. This is off by 33 thousandths. That's a fun word to say. All right, so what about scale 3? What does scale 3 have to say? So technically this is smaller. This is less than 5, right? Should I still do 4.98 minus 5? I can, But if that makes you uncomfortable, if you'd rather do 5 minus 4.98, you honestly can. Why does this not matter? I just want to know how far apart these are. So whether it's positive or negative doesn't really matter. I just need to know how far apart they are. And if I subtract these, I get 0.02. Okay, so which one is the most accurate? This one is off by 1/100th. This one off by 2/100ths. Which of those numbers is smaller? 1/100th or 2/100th? 1/100th. That guy wins. Dun dun dun. This scale right here, this one is the most accurate. And again, why is it the most accurate? Because this right here, this number, is the smallest. So whichever one is the smallest and therefore closest, that's going to give us the most accurate scale. This one is off by more, this one is off by more. This one's the closest, it wins. All right, so those are the two things we got going on here. Again, precision and accuracy. Precision, smallest unit or piece of a unit. So you're just comparing. Accuracy is how close, how far each value is from the real thing. So we look at how far apart they are through subtraction and figure out which is the smallest gap between reality and our measurements that are off. All right. I don't expect this to stay in your brain. It doesn't stay in my brain very well, quite frankly, which is why we write it down, okay? So write it down so that you've got access to it later and just keep thinking, okay? All right, thanks.